1 is equal to T01 minus C1 square divided by 2Cp. By substituting value of T01, which is 335 minus C1 square by 2Cp is C1 square. We have find out the value of C1 as 114.39 meter per second. By substituting that value, you will be getting C1 is 114.39 square divided by 2 into the value of Cp is 1005. Okay. Now on calculation, you will be getting the value of T1 as 328.49 Kelvin. 328.49 Kelvin. The value of T1 can be found out by using these formulas, and the value of T1 has been calculated as 328.49 Kelvin. Now with this value of T1, you can find the value of P1. That is by using the relation P1 divided by P01 is equal to T1 divided by T01 gamma divided by gamma minus 1. Okay, we know this equation, that is from isentropic process. We know that T1 by T2 is equal to P1 by T2 to the power of gamma minus 1 divided by gamma. If we consider, in order to find the pressure, P1 by P2 will be equal to T1 by T2 to the power of gamma divided by gamma minus 1. We will be getting this equation. We know the value of P01, T1 and T01. By substituting the value of P01, T1 and T01 in this equation, you can find the value of P1. That is, this will be equal to 1.02. P01 is 1.02 into 328.49 divided by 335 to the power of 1.4 divided by 1.4 minus 1 will be 0.4. And on calculation, the value of P1 will be equal to 0.952 bar. The value of P1 will be equal to 0.952 bar. Now we have find out the value of P1, and if you substitute the value of P1 in this equation, you can get the value of rho 1. P1 and T1 in this equation, you can find the value of rho 1. That is, the density rho 1 will be equal to P1 is 0.952 into 10 to the power of 5 Newton per meter square divided by R is 287 into the temperature is T1 is 328.49, and on calculation you will be getting 1.01 kg per meter cube. This is what the value you have arrived by calculating. Okay. Now, if you see, we have got a value of rho 1. We have got the value of rho 1. And if you substitute this value of rho 1 in this equation, that is in this equation, you can find the value of Cx1. Okay, you can find the value of Cx1. Therefore, Cx1 will be equal to 5 divided by the value of rho is 1.01 into area is 0.0412, which will be equal to 120.16 meter per second, which is equal to 120.16 meter per second. And now you just relate these two values, that is Cx1 value. You have got the value of Cx1 as 120.6 meter per second, and you have assumed the value of Cx1 as 114.39 meter per second, where the variation is large. Okay. So the assumption which you have made is totally wrong. That is the difference between the value of Cx1 which you have assumed and which you have assumed and you have calculated is very large. Therefore, this value of Cx1 and the density which you have find is wrong. That is the consideration you have made is wrong. Therefore, again you should make another trial to find the value of Cx1 and rho 1. Okay, and another again you should find the value of Cx1 and rho 1 by assuming some other value. That is, you can assume the value of Cx1 as 125, 130, 140 in order to find the value of rho 1. Okay. கண்ணா இது வரைக்கும் ஏதாவது டவுட் இருக்கா? ஒரு நிமிஷம். கண்ணா இது வரைக்கும் ஏதாவது டவுட் இருக்குங்களா? இது புரிஞ்சுதுங்களா? அதாவது நம்ம ஜெனரலா அசியூம் பண்ணணும்டாக்கன்னா ஓகேங்களா, நம்ம வேல்யூ ஆஃப் Cx1 ரோ 1 அசியூம் பண்ணியிருக்கோம். அது கரெக்டான இப்போ நம்ம செக் பண்ணோம், நம்ம பண்ண அசியூம் பண்ணது. பட் நம்மளுக்கு வந்து வேரியேஷன்ஸ் வந்து லார்ஜா இருக்கனால நம்ம அகைன் திருப்பி வேற ஒரு கன்சிடரேஷன் வந்து வைக்கணும். ஓகேங்களா, அந்த Cx1 வேல்யூ அப்படி வச்சு ஃபைண்ட் அவுட் பண்ற வேல்யூ வந்து இன் கேஸ் கரெக்டா இருந்தா நம்ம வந்து ப்ரொசீட் பண்ணிக்கலாம். ஓகேங்களா?
ஓகே சார்.
ஓகேவா? Now we can make the second assumption. Let C1 is equal to Cx1 is equal to 123 meter per second. Now we are considering the value of Cx1 as 123 meter per second since the value which we got is somewhat around 120. You can take 121, 122, 123 up to 125 you can take and check the value. Now in order to make it simple, we have take the middle number which is 123. From 121 to 125 you can take any value, but in order to make it more easier we have taken the middle value which is 123. Now again with this value you should find the value of rho 1. We should find the value of rho 1, and again by substituting the value of Cx1 in the equation, in this equation you should find the value which you have obtained is correct or not. Okay, now in order to find the value of rho 1 you should find the value of P1 and T1 with respect to this value of T1. So again T1 will be equal to T01 minus C1 square divided by 2Cp. Now we know the value of T01 which is 335 minus, now the C1 square value is 123 meter per second. Here for calculating the value of T we have considered the value of C1 square as 114.39. Now we are considering it as 123. Therefore, you will be getting 335 minus 123 whole square divided by 2 into 1005. Okay. By calculating, you will be getting the value of T1 as 327.473 Kelvin. Okay. Now you can compare the value of T1 with this equation. T1 here you got 328.49 Kelvin. But if you consider the value of C1 as 123 meter per second, you are getting the value of 327.47 Kelvin. Okay. Now again with the value of T1, T01 and P01, you can find the value of P1 by using the isentropic equation. Therefore, the value of P1 will be equal to, the value of P1 is equal to P01 into T1 divided by T01 to the power of gamma divided by gamma minus 1. And on substituting, you will be getting 1.02 into 327.473 divided by 335 to the power of 1.4 divided by 0.4. Okay, divided by 0.4. you will be getting the value of P1 as P1 is equal to 0.942. Okay, of P1 as 0.9 bar. Now with the value of P1 and T1, you can find the value of rho 1. Okay, therefore density rho 1 is equal to density rho 1 is equal to P1 divided by R T1. We know that value of P1 is equal to into 10 to the power of 5 divided by R is 287 into value of T1 we have found it as 327.473. By calculation you can get the value of rho 1 as 1.0023 kg per meter cube. Okay, now we have found out the value of rho 1, and again check the value of Cx1. That is, we need to find the value of Cx1. We need to find the value of Cx1 by using these equations. Okay, therefore C1 is equal to Cx1 is equal to m dot divided by, that is mass flow rate divided by density into area. Mass flow rate, this equation C1 is equal to Cx1 is equal to mass flow rate divided by density into area. Therefore mass flow rate is equal to 5 divided by density is 1.0023 into area is 0.0412. Okay, if you calculate, you will be getting the value of 121 meter per second. 121 meter per second. Now the value of Cx1 is 121 meter per second, which is somewhat close with relate to the value which we have assumed. Okay, so we can proceed with these values. So we can proceed this value as 121 meter per second. The value of Cx1 is equal to 121 meter per second. Okay, because the value which we have assumed is 123 meter per second and the value which we have attained is 121 meter per second, which is the difference which is about around 1% only. Therefore it is a considerable amount for making it as a value. Therefore we can now finalize the value of Cx1 as 121 meter per second. Therefore the value of C1 is equal to Cx1 is equal to 121 meter per second. So we can finalize this value as the axial velocity component. So we have find out the axial velocity component. Okay, இது புரிஞ்சிச்சுங்களாக்குனா? இந்த ஸ்டெப் வரைக்கும் புரிஞ்சுதுங்களா? புரிஞ்சுதுங்களா? அதாவது நம்ம அசியூம் பண்ண வேல்யூவும் நம்ம கண்டுபிடிச்ச வேல்யூவும் கிட்டத்தட்ட மோர் ஆர் லெஸ் சிமிலர் வேல்யூவாவே இருக்கு. ஓகேங்களா? அதோட டிஃபரன்ஸ் பாத்தீங்கன்னா which is around 1% தான். பட் இங்க எடுத்துக்கிட்டீங்கன்னா உங்களுக்கு வந்த வேல்யூ வந்து 120 இருக்கு. பட் நீங்க அசியூம் பண்ண வேல்யூ வந்து 114 தான் இருக்கு. அதனால இந்த ரெண்டுத்தோட டிஃபரன்ஸ் ஓட பெர்சன்டேஜ் வந்து கம்பேரிட்டிவ்லி அதிகமா இருக்கு. அதனால தான் நம்ம இந்த வேல்யூ வந்து பண்ணல. பட் இங்க நீங்க கன்சிடர் பண்ணியிருக்க வேல்யூக்கும் நீங்க வந்து உங்களுக்கு நீங்க ஃபைண்ட் அவுட் பண்ணியிருக்க வேல்யூக்கும் உள்ள டிஃபரன்ஸ் வந்து அரௌண்ட் 1% தான் இருக்கு. ஓகேங்களா? அதனால we have finalized this value as the Cx1. Okay, now we can proceed with the question in order to find the value of beta 1 MW1 and again alpha 1 beta 1 MW1 with respect to inlet guide wave. Okay, now we should consider the two cases, that is with inlet guide wave and without inlet guide wave. Therefore from the question, determine the air angle at the inducer blade entry and relative Mach number. First we should find the air angle beta 1, that is air angle this value of beta 1 and MW1 with respect to this diagram, that is flow through the inducer section without inlet guide wave. Okay, Now from the diagram, from the velocity triangle, consider this as figure 4. Okay, consider this as figure 4. This is the actually the figure 4. Okay, நம்ம வந்து இது வந்து கண்டினியூஸா வச்சிருந்தோம். அதுல வந்து இந்த ஃபிகர் வந்து இது வந்து ஃபோர்த் ஃபிகர். ஓகேங்களா, நீங்க வந்து வெலாசிட்டி ட்ரையாங்கிள் வந்து இத செஷன் பார்த்தீங்கன்னா உங்களுக்கு தெரியும். இந்த டயக்ராமோட ஃபிகர் வந்து நம்ம நம்பர் 4னு கன்சிடர் பண்ணியிருப்போம். அதனால அதே ஈக்குவேஷன் வந்து யூஸ் பண்ணியிருப்போம். ஓகேங்களா, இது வந்து ஃபிகர் 4. இது வந்து this is figure number 5. ஓகேங்களா, இது வந்து நீங்க இப்ப ரெஃபர் பண்ணாலும் உங்களுக்கு வந்து சேம் ஈக்குவேஷன் சேம் டயக்ராம் தான் இருக்கும். ஓகேங்களா, அப்போ from the velocity triangle, that is figure 4, if you the value of tan this beta, if you need to find the value of this value beta 1. Okay, if you consider it as tan beta 1, if you consider it as tan beta 1, that is tan beta 1, which is equal to opposite side by adjacent side. Here the opposite side is cx1 and the adjacent side is u1. The opposite side is cx1 and the adjacent side is u1. Okay, we know the value of cx1, we know the value of cx1, but the value of u1 is unknown. You should find the value of u1 in order to find the value of beta 1. We know that u1 is equal to pi d1 n1 divided by 60. We know this formula for peripheral velocity, which is equal to pi d1 n divided by 60, and on substituting that you can get u1 is equal to pi d1 n divided by 60. The value is find out as pi into the value of d1 is 0.175. The value of d1 is 0.175. This value d1 is being found out from the equation, that is d1 is equal to 1 divided by 2 dh plus d of t. Therefore this is will be 0.5 into dh is 0.1 plus this is 0.1 plus 0.25. Okay, this is the hub diameter and another one is the tip diameter, and you will get the value of d1 is equal to 0.175 meter. Therefore by substituting the value of d1 is equal to 0.175 meter in this equation, you can get the value of u1. Therefore u1 is equal to pi into 0.175 into value of n is 7200 divided by 60. Therefore the value of u1 will be equal to 65.97 meter per second. 65.97 meter per second. And if you substitute this value in this equation, you can get the value of beta 1. That is, this implies beta 1 will be equal to tan inverse of cx1 divided by u1, which will be equal to the value of cx1 is 121 tan inverse of 121 divided by 65.97. Okay, from this on calculation the value of beta 1 will be equal to 61.4 degree. 61.4 degree. Therefore we have find out the air inlet at the inducer blade, which is equal to b1 is equal to 61.4. okay, now we should find the value of Mach number. We should find the value of Mach number, relative Mach number, and the relative Mach number is given by the equation MW1 is equal to W1 divided by A1. While explaining the dimensionless numbers, that is the dimensionless number in the first unit, I have already said Mach number is equal to velocity of the fluid divided by velocity of the sum. Here you have considered it as a relative velocity, therefore we are considering it as m of W1, which is equal to W1 divided by A1. Generally, for finding out Mach number, you will be using the velocity of the fluid, which will be equal to c. But in this case, we are using the relative system for finding out the Mach number. Therefore, we are replacing the value of c1 as w1. Therefore, this is the relative velocity of the fluid. The velocity of sound. The velocity of sound is given by an equation. This you just remember, A1 will be equal to root of gamma r into T1. Okay, this is the velocity of sound. This is velocity of sound in the fluid. Okay. W1 is the velocity of the fluid, relative velocity of the fluid, where A is the velocity of the sound in the corresponding fluid, and it is given by an equation root of gamma r T1. So, in order to find the value of MW1, you should find the value of W1 and A1. Okay, but the value of W1 remains unknown. So, we should first find the value of W1. In order to find the value of W1, you know the value of this Cx1 and U1. You can either use cos theta or you can use sin theta in order to find the value of W1. Now, if we consider as sin beta 1 which will be equal to sin beta 1 is equal to opposite side by hypothesis. Opposite side is Cx1 divided by W1. Cx1 divided by W1. Therefore, sin beta 1 is equal to Cx1 divided by W1, which will be equal to W1 is equal to Cx1 divided by sin beta 1. Okay. We know the value of beta 1, which is 65.97. Therefore, if you substitute that value, you will be getting Cx1 is equal to 121 divided by sine of 65.97. Okay, and you will be getting the value of W1 as 137.8 meter per second. So we have found out the value of W1, and now we should find the value of A1 in order to find the value of MW1. Therefore, A1 is equal to root of gamma RT1. If you use this equation, you can find the value of A1. Therefore, A1 will be equal to root of gamma RT1, which is equal to 1.4 into 287 into 327.473, which is the T1 which we have found out. That is this value. This value T. So we substituting this, you can get the value of A1 as 362.737 meter per second. Okay, this is the velocity of sound in the corresponding fluid, and this equation is from figure 4. Okay, this equation we can derive from figure 4. Now, if you substitute the value of W1 and A1 in this equation, you can find the relative Mach number. Mach number without the inlet guide vane. Therefore, MW1 is equal to W1 is given as 137.8 divided by 362.737, which will be equal to 0.38. Therefore, the relative Mach number without inlet guide vane is being calculated as 0.38. Okay. Can you understand this?
Yes, sir.
ஓகேங்களா, புரிஞ்சுதுங்களா?
Sir, புரிஞ்சுதுங்க sir.
Okay. Now the second subdivision is if inlet guide vane are used to obtain the straight inducer section, determine the air angle at the inlet guide vane exit and the new value of relative Mach number. If in this diagram there is no inlet guide vane, so for that corresponding diagram we have find out the value of the relative Mach number. But if you consider the flow through the inducer section with inlet guide vane, that is this is the inlet guide vane, now you should find the exit velocity, that is now you should find the exit air angle at the inlet guide vane. This is the exit air angle at the inlet guide vane, that is beta 1 alpha 1. You should find this both values in order to find the Mach number, the relative Mach number at the exit of the inlet guide vane. Okay, therefore we should find this value. Okay, the axial entry of the air into the inducer is obtained by employing the inlet guide vane, that is we are using this as the inlet guide vane in order to find the relative Mach number for this corresponding question. Okay, therefore alpha 1, we should find the value of alpha 1. For finding out the alpha 1, you can consider as tan alpha 1 is equal to, tan alpha 1 is opposite side by adjacent side. Opposite side is cx1 divided by u1, cx1 divided by u1, which is cx1 divided by u1, which will be equal to, that is alpha 1 will be equal to tan inverse of cx1 divided by u1. cx1 is the opposite side and u1 is the adjacent side. You know both this value of cx1 and u1, therefore by substituting you can find the value of alpha 1. Therefore this will be equal to tan inverse of value of cx1 is equal to 121 divided by the value of u1 is 65.97. Therefore the value of alpha 1 will be equal to, therefore the value of alpha 1 will be equal to 61.4 degrees. 61.4 degree. On calculation you can get the value of alpha 1 as 61.4 degree. And here you can see the value of beta is equal to 90 degree. Here you can see the value of beta is equal to 90 degree. This is value of beta which is equal to 90 degree. From this we know that this is case 2. Okay, consider this as case 2. And we know that the value of beta 1 is equal to 90 degree, and here the value of cx1 is equal to w1, which is equal to 121 meter per second. You can see the diagram here, that is the value of w1 will be equal to cx1. Therefore we no need to find the value of w1 in this case, that since it is equal to cx1. Therefore the value of cx1 is equal to w1, which is equal to 121 meter per second. Okay, 121 meter per second. Now we need to find the value of c1. We need to find the value of c1. We need to find the value of c1 and t1 and again a1 in order to find the value of mw1 for this inducer section with inlet guide vane. Okay, the value of relative number will be different on the account of value of w1 and c1. Since there are different values for w1 and A1, you should find the value of C1 in order to find the value of MW1. Therefore, from this diagram, if you consider sine alpha 1, this will be equal to Cx1 divided by C1. Cx1 divided by C1. From this, C1 will be equal to Cx1 divided by sine alpha 1. Okay, from this you can find the value of C1. We know that Cx1 is equal to 121 divided by sine alpha 1. We know the value of alpha 1 as 61.4 degree. By substituting both these values, you can find the value of C1. Therefore, from the velocity triangle number 5, figure 5, C1 will be equal to Cx1 divided by sine alpha 1. We know that Cx1 is 121 divided by sine of 61.4. Therefore, the value of C1 will be 137.8 meter per second. 8 meter per second. Now, we should find the value of A1. That is, we know that MW1 is equal to W1 divided by A1. MW1 is equal to W1 by A1. We have found out the value of W1 as Cx1, which is equal to 121 meter per second. But the value of A1 you should find. The value of A1 you should find. Again, the value of A1 will be equal to, the value of A1 will be equal to gamma RT1 root of gamma RT1. Now, you should keep in mind that you cannot substitute the value of T1. You cannot substitute the value of T1. That is the value of T1 where it is. You cannot use this value of T1. Okay, you cannot use this value of T1 now, since the value of C1 itself has changed. Here, the value of C1 is considered as 123 meter per second. And again, we have considered it as 121 meter per second. And we have confirmed the axial velocity as 121 meter per second. But here we have found out the value of C1 as 137.8 meter per second when we consider inlet guide wave. Therefore, the velocity component is different for the inlet guide wave section compared to that of the inducer blade without the inlet guide wave section. Therefore, you cannot use the temperature value which we have obtained from the inducer section without inlet guide wave. Therefore, you should find the value of T1 in order to find out the value of A1. Okay. Again, the value of T1 will be equal to T01 minus C1 square divided by 2Cp. By using this equation, you can find 335 is the stagnation temperature minus, here C1 square is 137.8 whole square divided by 2 into 1005. And the value of T1 will be equal to 325.553 Kelvin. Therefore, there is a change in the temperature when we consider the inlet guideway section for the inducer section. Okay. Therefore, the value of T1 is 325.553. But in this case, you have substituted the value of T1 as 327.473. So you have obtained the value of A1 as 362.732. Now, again, since there is a change in temperature value, you should find the value of A1. Therefore, the velocity of the sound in the fluid will be equal to 1.4 into 287 into 325.553 to the root. And on calculation, the value of A1 will be equal to 361.67 meter per second. Okay, you have find out the value of A1, and again you should find the value of MW1 by considering the inducer section. Now considering the inlet guide vane in the inducer section. Therefore, the value of MW1 will be equal to W1 divided by A1. Here the value of W1 is equal to Cx1 according to this equation, and according to this diagram you can see Cx1 is equal to W1. Therefore, we can substitute the value of Cx1 as W1. So the value of Cx1 we have found out as 121. Therefore, by substituting the value of W1 as 121 divided by 361.67, you can find the value of relative Mach number system as 0.334. Okay, this is the relative Mach number with respect to the inlet guide vane in the inducer section, and this Mach number is the flow through the inducer section without inlet guide vane. Okay, there is certain difference in the Mach number. Okay, this is how you should solve the problem when the axial velocity component is not given. That is, you should make a trial and error method in order to find the Cx1 value. Then you should proceed with the finding of the relative Mach number. But in some problem, the value of this Cx1 might be given. So you can simply proceed with the formulas from this step to find the value of the relative Mach number. Okay. Do you have any doubt in this? Can I ask other doubt இருக்குங்களா?
சார் இல்லைங்க சார்.
எல்லாருக்கும் புரிஞ்சுதுங்களா?
எஸ் சார்.
டிஃபிகல்ட்டி இருந்தா ஒன்ஸ் கம்ப்ளீட் பண்ணிடலாம் இந்த செஷன் இதோட.
ஓகேங்க சார்.
ஓகேடா கண்ணா. கண்ணா இதோட உங்களோட தேர்ட் யூனிட் வந்து மோரலஸ் கம்ப்ளீட் ஆயிடுச்சு கண்ணா. ஓகேவா? நான் சொன்ன மாதிரி அந்த ஸ்லிப் ஃபேக்டரும் அந்த டிஃப்யூசர் அனாலிசிஸ் மட்டும்தான் நம்ம பண்ணல. அதுக்கான மெட்டீரியல் வந்து உங்களுக்கு இன்னைக்கு நான் சென்ட் பண்ணிடுவோம். ஓகேங்களா? நீங்க அதை ரெஃபர் பண்ணிக்கலாம். அந்த எண்ட் ஈக்குவேஷன்ஸை மட்டும் பார்த்துக்கோங்க. எல்லாத்துலையும் அந்த ஸ்லிப் ஃபேக்டர்லையும் சரி, அந்த டிஃப்யூசர் அனாலிசிஸோட எண்ட் ரிலேஷன் வந்து பார்த்துட்டுங்க. ஓகேங்களா? அந்த ஸ்லிப் ஃபேக்டர்ல வந்து ஒரு 2-3 மெத்தட் இருக்கும். அந்த 2-3 மெத்தட்லையும் வேல்யூ கொடுத்துருப்பாங்க, ஒரு ஈக்குவேஷன் கொடுத்துருப்பாங்க. அந்த ஈக்குவேஷன் வந்து என்ன அப்படிங்கிற மாதிரி கேட்பாங்க. ஓகேங்களா? அப்படி கேட்டாங்கன்னா நீங்க அந்த ஈக்குவேஷன் வந்து யூஸ் பண்ணிக்கணும். ஓகேங்களா?
எம்சிக்யூக்காங்க சார்.
ஆமாப்பா, எம்சிக்யூக்கு தான் சொல்றேன்.
ஓகே சார்.
ஓகேங்களா? இப்போ என் செமஸ்டர்ல எம்சிக்யூ கொஸ்டின் வந்து நீங்க 30 கொஸ்டின்ஸ் அட்டெண்ட் பண்ற மாதிரி இருக்கும். ஓகேங்களா? அந்த காரணத்துக்காக நீங்க வந்து இந்த ஈக்குவேஷன்ஸ்லாம் எண்ட் ஈக்குவேஷன்ஸ் வந்து உங்களுக்கு மோரலஸ் எல்லா இதுக்குமே தெரிஞ்சிருக்கணும். ஓகேங்களா? அது கொஞ்சம் பார்த்துக்கோங்க.
ஓகே சார்.
ஓகேப்பா
சார்.
சொல்லுங்க ராகுல், சொல்லுங்க
சார். இப்போ ஃப்ரைடே வந்துட்டு நீங்க 11:45 to 12:45 டெஸ்ட் வைக்கிறீங்களா சார்?
ஆமாப்பா.
நார்மலா அந்த வீக்லி டெஸ்ட் வைக்கிறீங்களா சார்? 11:45 to 12:45. அது வந்துட்டு கொஞ்சம் 1 hour பிஃபோர் வச்சீங்கன்னா கொஞ்சம் நல்லா இருக்கு சார். ஏன்னா கிளாஸ் முடிஞ்சு ஒரு 1/2 an hour போதும் சார் லஞ்ச் சாப்பிட்றதுக்கு. அது முடிஞ்சு சும்மா 2 hours இதுக்காகவே வெயிட் பண்ற மாதிரி இருக்கு சார். அதனாலதான் வேற எதுவும்
என்ன லஞ்ச் சாப்பிட்றப்பா? நீ 10 மணிக்கு சாப்பிட்டு
இல்ல சார், பிரேக்ஃபாஸ்ட் சார். காலையில என்னன்னா 8:30 to 9:30 கிளாஸ் இருக்கு சார். அது முடிஞ்சா ஒரு